Okay, as luck would have it, Zoom was having a hard day. Okay, so what I've done is I made a brief PowerPoint over what I covered in 207 this morning, and I'm going to kind of walk you through that brief recording. All right, I'm going to kind of just walk you through it rather than there being a recording of the class because it didn't record. So you're welcome. So let me kind of show you what we did today in statistics. All right, let me kind of come over here and share my screen, I hope. All right, let's see if technology will be our friend now. Okay, so here's kind of what we did. All right, we went over the homework. So if you had trouble doing that binomial homework, then make sure that you come see me, set up an appointment, you know, kind of whatever you need to do. We talked about the test. That'll all be on Moodle, okay? So make sure you do check Moodle for your homework and for clarification about your test and what it's on and when it is, okay? Now, here's what we did. We had to be able to find the mean and standard deviation of a binomial problem. All right, so the question would be like this. You must take a 10-question test. Each question has A through D options. If you must guess at each question, what's the mean number of correct answers that you can expect and what's the standard deviation? Now, you already know how to find mean and standard deviation for test 2 on one kind of thing. So think about all the way through your homework. You've already found mean and standard deviation before, but it was on a probability distribution table. All right, remember, that's when you said every X times the probability all the way down the table, remember, and you added them up. So there's a formula for a probability table for mean and standard deviation. All right, but look at this problem. There's not a table. So I don't think there's any way on the test to get the two confused. Either there is a table or there's not a table, okay? If there's not a table, we hope it's a binomial problem because they're very simple to do. So look at this. I don't see a table, so I think, oh my goodness, they asked me to find the mean. The only time on test 2 I've got to find the mean is either a probability table or a binomial problem. I don't see a table, so let me check and see if it's binomial. All right, well, is it binomial? Well, here's what they're saying. You walk in class, you're caught cold, you have no idea what's going on, and you have to just guess at every question. Well, either you get it right or you get it wrong. So there are 2 options. All right, so that's by 2. What's your chance of getting every question right? All right, now think about it. A, B, C, D. Okay, so what's your chance of just guessing and getting the first question right? Do you see that it's like 1 out of 4? Because there are 4 options and only 1 is right. Okay, if you guess at number 7, because you're just guessing and there are 4 options and only 1 is right, your probability of getting it right there is 1 out of 4. All right. So this is a binomial problem. All right, well now if it's a binomial problem, look on your formula sheet. Here's the formula on your formula sheet for the mean of a binomial distribution. So it's just on your formula sheet, it's just n times p. That's it. So look up here, remember n is always your total in every problem, and it says that you've got 10 questions. So n's going to be 10. All right. Remember, P's got to be the probability of what you're doing. So you want the mean number of correct answers. So P's got to be your chance of being correct. So like we said before, what's the probability that you get a correct answer? On the bottom is always your total. So when you're guessing, how many options do you have? A, B, C, D is 4. How many of those are correct? Only 1. So if you like decimals better, you know, you can put that on your calculator and get decimal 25. So there's your P. So all you do is come over here and you take your N and you multiply by your P. So when you do that, you're going to get 2 5/10. So your mean is 2 5/10 on this problem. So if you were just guessing, you could expect to get a little over, you know, on the average, 2 problems right, 2.5 problems right. Now you understand you can't really get 2.5 problems right. All right, this is an average. That means if you took a 10-question test, you'd get 3 right one time. You might get 4 right. You might miss them all. You might get 1 right. If you added all those up and divided by how many times you did it, the average is about 2.5 correct answers. So then it asks you, what's the standard deviation? Well, this is the formula on your sheet for standard deviation. The square root of n times p times q. So see, n is still 10. Your p is still 1 out of 4. All right, so that's going to be 0.25, 25 hundredths. How do you know q's? How do you find q's when you know p? Remember, q is 1 minus p. So if I take 1 and subtract 0.25, I'm going to get 0.75. So I'm going to go do the square root of n, 10, times p, which is 0.25, times q, which is 0.75. All right, so let me get my calculator. Okay, so if I take 10 and multiply by 25 hundredths, and then multiply by 75 hundredths, oops, looks like I get about this. You try it on your calculator, so freeze it and try it. Make sure you get 1.875. So that's what I get when I say 10 times 25 hundredths times 75 hundredths. So now I'm going to put approximately equal to, because I'm sure I'm going to have to round it. So when I take the square root of that answer, looks like I get about 1.4. So the standard deviation is about 1.4. Okay? Now what if it wanted variance? Variance is just your standard deviation, remember, squared. So you could do that 1.4 and you could square it and get to be about 1.96. Now that's a little bit off because we rounded here and got some error. You know, that would be a better approximation, but 1.96. So what I'm going to expect you to do is just take whatever you got for your standard deviation and square it. So that's how you do mean, variance, and standard deviation for binomial. Okay, they're on your formula sheet. It's super simple. And the way I know it's not a probability distribution is I don't have a table. Okay, all right, now let's go look. Now this is kind of where your test ends. Now, I wrote an outline on the board of what's on your test. All right, so you can get that copied from somebody else. But basically, you have to be able to find a probability. That's one thing. So that could be one thing one time, or it could be binomial, or it could be a connector word. So remember, your connector words are and, or, and given that. Another thing you have to be able to do for your test is you got to be able to find odds. And again, you have 2 kinds of odds: odds against an event and odds in favor of an event. So make sure you go back and look over that. Another thing that's going to be on the test are finding totals. How many ways can you do something? Remember, that's either counting principle, permutations, or combinations. If order does not matter, you have to use combinations. If order does matter, then you can always use the counting principle. Okay? Then you've also got to be able to find the mean and standard deviation. And it might be a probability distribution table or it might be binomial. So that's kind of an outline of what's on your test. Okay? So I'm going to email this to you, but next week, you're not going to zoom in on your regular day. I'm going to make a video for you to watch on new material. So if you're normally on Zoom on Tuesday, instead, you're going to watch a video on Tuesday. If you're normally in Zoom on Thursday, then you're going to watch a video on Thursday. The day that you're in class, we're going to work review sheets. Okay, so that's why I'm not really zooming you in, because you just be watching silence. Because I'm going to let y'all kind of talk to each other and work through a sheet with all the probability problems mixed up. That'll be sort of like your test. Okay, and then your test is, I have to look it up. I think it's the 20th. It's on Tuesday of not Tuesday of next week, but Tuesday of the next week. Because we're going to flip it than it was last time. Last time it was on a Thursday, so this time it's going to be on a Tuesday. Okay, but I'll send an email out that kind of warns you about that. So this is where the material stops. So the mean, and standard deviation of a binomial problem is the last thing on your test, okay? So what we're about to start now is not on your second test, it'll be on your third test. But I don't have time to just stop and quit, okay? So your test is going to be on chapters 4 and 5. And so all that'll be on Moodle. All right, so let's go look at the new material. All right, so this will be the beginning of test 3. We're talking about a normal distribution. Now, we've already talked about a normal curve before on test 1, remember? It looks like this where we draw the normal curve. Now remember, on the normal curve, the median and the mean and the mid-range are all the same number. All right, so that's how I know. I know that this is the median position, but the reason I have the mean is they're the same number. So these are the kind of questions that we answered before. Okay, you could have had these questions on test 1. So this is a review. I'm telling you that IQ scores are normally distributed. So you would have to know that it's normally distributed for this to work. I'm telling you that IQ scores have a mean of 100 and a standard deviation of 15. Now, where did they get that? They got it the same way that we get it in the real world. They've given millions of IQ tests, added the scores up and divided by how many they got, and the average was 100. And they did standard deviation using that shortcut formula the way we did for test 1. So I would give you this though. Now, what percent of people have an IQ between 85 and 115? Now, the reason you should be able to answer that question already, remember what we said before test 1. If you take the mean and you add 1 standard deviation, and you take the mean and you subtract 1 standard deviation, if your mean's 100 and you add a 15, you're up to an IQ of 115. If you take your mean and you subtract a standard deviation, you're down to an IQ of 85. And remember, you're supposed to have this percentage memorized. All right? So I want to know this area right here. Well, you memorized that between 1 standard deviation below and 1 standard deviation above was 68%. So the answer to this would be 68% because you did what I told you and you memorized it. Now this one though, think about why this is really kind of the same question. So if 68% of people have an IQ between 85 and 115, I'm saying, so then what's the probability that a randomly selected person has an IQ between 85 and 115? Do you see that it would be 0.68? Now, it can't be 68 because it's a probability, and probabilities have to be between 0 and 1. Okay? So asking you the percentage, asking you the probability is really the same kind of question. Now, look at this one. Let's make sure we're clear about this one. What if I said, what's the probability that a person has an IQ above 115? So I'm talking about these people. Now, do you understand that if I'm talking about this right here, I've already used up 68%. All right, so 68% are already here. So how much would that leave me to work with? I mean, if I'm trying to figure out here, think about it. What's the whole curve? What's all of something? Isn't all of something 100%? Well, I've already used up 68%. So what does that leave me to work with? Does that leave me 32% to work with? So why isn't the answer 32? So do you understand that the 32 has got to be split between here and here? This thing is symmetric, so this area has got to be the same as that blue area. So I have to split that 32 in half. So when I take that 32 and I divide by 2, I'm going to get 16. So that tells me that this area right there is 16%. And that area right there is 16%. If you add 16 and 16 and 68, I get all of it. I get 100%. So what's the probability then that somebody has an IQ above 115? Well, if I know that 16% of the people are above 115, do you see that this answer is just 0.16. 16% is a decimal. Okay. Now, what happens though is sometimes this picture is not sufficient. So what if instead of saying what's the percent of the people have an IQ between 85 and 115, what if I said between 90 and 115? Or if I said between 90 and 110? Well, see, 90 would be about right there, maybe, and 110 would be about right here. And I want to know what percent of people have an IQ between those two. Well, I don't know. I know it's less than 68%, but I can't, with this picture here, give you exactly the right answer. So that's where we're going. We're going to learn how to do those problems. All right. So, get my marker back. Let's go look at what we would do. Here are your steps on finding probabilities for a normal distribution. The first thing you have to do is you have to draw a picture and shade the area for which you're looking. I would say what you're looking for, but then that ends the sentence with a preposition, and then the English department will be mad at me. Okay? So you draw a picture and shade the area you're looking for. All right? Then you use the calculator. The calculator does all the work. You're going to go to a distribution, just like you did for a binomial distribution. This time you want a normal distribution. So because of that, you have to go to second Bayes. Second Bayes is your distribution. This time, you're looking for normal CDF. Now again, just like with binomial, there's also a normal PDF. But you are never going to pick it. You were always going to pick normal CDF. All right, because this is like cumulative. See, there's a bunch of IQ scores, not just one IQ score awarded. We're about all the IQ scores between 95 and 110. So they're never going to ask you, what's the probability somebody's got an IQ score of 11 or 129? Okay, so they're just not going to ask you any of those. So you don't have to worry about it. You're always going to pick the normal CDF. Then it wants you to type in the left endpoint on the shading. So on the left part of the shading, what's your endpoint? Comma. It wants the right endpoint of your shading and a comma. Then it wants the mean and a comma and the standard deviation. So look at this problem. What's the probability that a randomly selected person has an IQ between 95 and 110? So when it says draw a picture, I mean I'm drawing the normal curve. What goes in the dead center of a normal curve is the mean. So I told you before the mean was 100. And I want it between 95, so 95 is smaller, so it's on the left, and 110, so it's on the right. Now, I can't tell by the picture if that's more or less than 0.5. I can't tell if it's more or less than half the picture, because I'm not drawing it to scale. All right, so here's what I do. I find second Bayes, I go down to normal CDF, and I typed in 95, because 95 is on the left side of this shading, comma. Why did I type in 110? Because that's my right endpoint. It's on the right side of the shadings where it ends. My mean is 100 and my standard deviation is 15. And when I close the parenthesis and I round it to 4 places, I got 0.3781. Almost 38%. But I want it as a decimal, 3 or 4 places. Okay? So it could not be simpler. All right? Now, let me show you one, though, where you have to kind of fool the calculator. All right, here's what I mean. Look at this one. Find the probability that a randomly selected person has an IQ above 120. So, first step is you draw your picture. So, I drew my normal curve. The mean is 100, so I'm putting the mean in the middle. And it wants above 120. So 120 is bigger, so I put 120 to the right of 100. And then it said above, so that's why I shaded above. So I need that area right there. Okay? So again, I'm ready. I write down normal CDF. Now, why did I write down 120? That's my left endpoint. Now, do you see that I don't have a right endpoint? I mean, nobody really knows what the highest IQ score could be. So when you don't know the right endpoint, put a ridiculously big number. Now, what I told them in class was, just for sake of easy, I put a bunch of 9s. Nobody's going to have an IQ above 9,999. They're just not going to do it. So I just put in, you could put 600. I don't know anybody's got an IQ above 600. So it doesn't really matter what it is as long as it's a ridiculously big number. It's just GAN uses a bunch of 9s all the time. Now, if it were weights of 18-wheelers, I might need some more 9s because they weigh thousands and thousands of pounds. And then I wrote down my mean and my standard deviation, and I rounded to 4 places, and I got 0.0912. Okay, so a ridiculously big number when you're missing your right endpoint. What if you're missing your left endpoint? Look at this one. Find the probability that a randomly selected person has an IQ below 92. Well, this time the right endpoint is 92, the mean is 100, and the standard deviation is 15. This time I'm missing my left endpoint. So I think, okay, well, nobody's going to have an IQ below 0. So I might use 0. Now, I'll be honest with you. I tend to just do the same thing all the time. So when I'm missing the right endpoint, remember what I said, when I'm missing the right endpoint, I am simply going to put in a whole bunch of 9s. So a lot of times when I'm missing the left endpoint, I put a negative and a whole bunch of 9s. Nobody's going to have an IQ below negative 90,999. So whether you put a 0 or this number, you're going to round to 4 places and get the same thing. So the reason I do a negative and a bunch of 9s is sometimes data can be negative. Like if we were doing average temperatures in Alaska in the winter, you can go below 0. So putting 0 as the left endpoint wouldn't make any sense. So just for sake of easy, when I'm missing the right endpoint, I put a bunch of 9s. When I'm missing the left endpoint, I put a negative and a bunch of 9s. Okay, so go try your homework. All right, and then, like I said, be looking for that email about next week, about watching the video for next week. Okay, so I hope, depending on whether you're in quarantine or whether you're running, whether you're off with the team, I hope that made sense. Come see me if it didn't. Shoot me an email. We can meet one-on-one in the conference room, or we can Zoom. All right, so I will see y'all next week in class whenever your in-person time is. All right.